Morning sir. This presentation is based on the second assignment of micro and nano manufacturing. Introduction. You can go to introduction part. In this presentation we are discussing two major topics which are hot embossing and injection compression molding. Hot embossing is a replication process especially suited for the replication of delicate micro and nano structures with high aspect ratios on thin layers. The process is very flexible because both mold inserts and the type of polymer can be exchanged quickly. It's why hot embossing machines are very popular for the laboratory use and for the replication of small series. The hot embossing process is an open tool technique where a semi-finished polymer sheet is put in between the upper and lower molding tool. The complete tool is evacuated in order to ensure the complete filling of cavities of the microstructure tool. And the polymer is heated up above its softening temperature. Softening temperature is basically the melting temperature or the transition temperature depending upon the polymer class, the polymer which we are using. And the softened polymer is pressed into the microstructure cavities. And this is the overall picture of the hot embossing process, in which we can see two molds, heated molds, and in between the molds we can see the polymer or the material which we are going to replicate or hot emboss. And finally the plate is cooled to obtain the hardened polymer material which we replicated here. And now we can discuss the features of the hot embossed product. First one, double-sided molding. This is a double-sided molding alignment, hot embossing. And the second point, in general, molding of all thermoplastic polymers, including high temperature polymers, we can done using the technique called hot embossing. And third one, the structure size down to nano range. That is, the dimensional tolerance we can attain is in the nano or the range which below that. And the final point, quick change of mold insert and polymer, which can be done in series, and the prototype with different polymer we can apply in this manufacturing process. Now we can go to the second topic, which is injection compression molding, which is also a popular manufacturing technique nowadays. Generally, compression molding is defined by the application of heat and pressure. While this is similar to that of injection molding process, the conventional injection molding process which we have studied in the previous lessons. At first, the polymer melt is injected in order partially to fill the mold, which is partially open. Then the compression stage is introduced, which leads to the final closing of the mold by squeezing the flow of melt. This compression stage is introduced to replace the packing stage of conventional injection molding. Since the pressure developed during the compression stage is significantly lower than that in the packing stage of conventional injection molding process. This is the pictorial representation of the injection compression molding process. We can see this is the same, similar to that of the conventional injection molding process, where we can see upper movable mold half, a charged lower fixed mold half, and ejector pin. We know the use of ejector pin, which is used to eject the injection molded part from the mold. Now finally we can discuss the advantages of the injection compression molding process. The first point, which is it have lower residual stresses. We know that the stresses decrease the strength of the polymer product, and lowering these stresses will be beneficial for the user. And the second point, lower molecular orientation and birefringence. And the third point is less and more even shrinkage and better dimensional tolerances. At the same time, this process maintains high output and good process control. That is, it's a very feasible and applicable process. And the fifth point, automation inherent to conventional injection molding. Automation can be done in this injection molding process, which we can get fast product and less consumption of time. And the sixth point, the process is especially useful for molding thin parts that require high quality and accuracy. However, the process requires careful timing of injection clamp position and force. We can understand that the This process need skillful persons to accomplish the desired product from this output of this product manufacturing process. And finally, the injection conversion molding is presently employed in making optical discs, where requirement for dimensional tolerance and the optical retardation are very stringent. Thank you. That's all.